Aditya came. Venkatesh came. Yeah, Venkatesh is also came. Okay. So I don't know remaining people, Raj Srivastav, Deepika, Gautam, and Balaji. So regularly people are all people are came. Very good. Okay, guys. So we are all using TCP/IP protocol suite in our communication. Okay. And also I'm going to add few things here. Look at here. It is okay. So we are using IP addresses. That is why it is showing bold. It's not required 14. Okay. We are using a IP addressing. We are using IP address, IPv4 and IPv6. Mostly IPv4 communication only. We are using. Okay, not IPX, SPX kind of protocols we are not using. Protocol suite we are using TCP/IP protocol only. Okay, and other protocols also there. And all these protocol suites are invented before OSI model came. And we are not using OSI also, open system interconnect, which use it to understand the network communication. Okay. So this OSI model is a standard model, which is standardized by ISO International Organization for Standardization. Okay. Next, and this is actually came from the IEEE, Institute of Electrical and Electronics Engineers. Guys, our internet, our IP addresses, the domain names, everything is controlled by these people. IETF, IANA, ICANN, these are all controlling what kind of IP address you should use it, what kind of domain names you should use it, private IP addresses, public IP addresses. These things will are controlling this one. So without their agreement, you cannot use any IP address. Private IP addresses, you can use it. Public IP addresses, compulsory. You have to go through this documents, permissions, purchases, kind of stuff. Even for a domain names also. Okay. So this is small point. So we are all using TCP/IP protocol suites, and we are using IP addresses. Okay. Mm. The cable we are using twisted pair cables. The cables, what are the cables we are, what is this? What cables, if in case you are using a cable, what cable we are using? So we are using twisted pair. Mainly we are using UTP. So mainly we are using IPv4, mainly we are using UTP. Of course, in some organizations also use in certain places like a STP also. Okay, shielded twisted pair cable, unshielded twisted pair cable. So we are using UTP mainly, IPv4 mainly. So globally we are using this kind of stuff. You are using TCP/IP model. Okay, so this organization names. So this is OSI model. Already I explained yesterday about your protocols and port numbers kind of stuff. That's we can see. what to do. So we better keep it in a separate page, fresh page. Okay, so then we will see. Okay, guys, see here it is. Current topic is voice model. After this one, so we'll see next time. So voice model is a networking model. Voice model is a networking model. In networking, we use this voice model. We don't implement OSI in any place. Just it is a reference model. Reference textbooks are not for a direct textbook. It is just for a reference purpose. Means to understand the concepts like that. So to understand network, you want to create a new network or maintain the network or troubleshoot the network. The OSI model is very useful. It contains 7 layers. It divides entire network into the 7 layer model. Okay, it contains 7 layers. Okay, so how from your source to destination and destination to source, how the communication is going on? What are the steps wise how it is going on with the communication to understand it? So we are using this OSM. Not only that one, guys, any issues are occurs. So we can understand which layer related issue it is. So based on that, we can able to troubleshoot it. Okay. This model is actually designed by IEEE and it is standardized by ISO, International Organization for Standardization. Okay, it is some kind of stand. Open system interconnect. Open system means any type of network from any type of device to any type of device communication it is. Windows to Windows, Linux to Linux, Windows to Linux, or maybe there is a Windows server to Linux client, or a Linux server to Windows client. Okay, so it is a network related comp. It's not related to operating system or it related to particular device. It is any type of device, any type of operating system. So OSI layers are applicable. And moreover, what is meant by open system interconnect means it is suitable for any kind of protocol suite you are using in your organization. Generally, we are using TCP/IP, but in a certain organizations like IBM and all, novel netware. Now, SAP using this novel netware. Okay, okay. So like this, any kind of protocol suits it. It is there. It is we can understand it through OSI model. Okay. So it is having 7 layers: application layer, presentation layer, session transport network, data link, and physical layers. These are the 7 layers of OSI model. The first layer is physical layer. The seventh layer is application layer. The layer numbers are in reverse in order. Okay. But the layers we always read from here to here. In certain textbooks, or some people are telling either in a colleges or maybe in a certain institutes, they will tell from the physical layer to application layer because of layer numbers are 1 to 7, not 7 to 1, right? So normally number 1 layer is application layer, number 2 data link, number 3 network, 4 is transport, 5 is session, 6 is presentation, 7 is application layer. So these are the 7 layers. Which one is correct? You have to read it from application layer to physical layer or physical layer to application layer. Which one is right? Both are right, guys. Both are right. But my hobby of teaching and understanding is from application layer to physical layer. Okay. But if you run already from physical layer to application layer, that is also correct. Okay. But do not interchange the layers. Like what are the OS layer, application layer, physical layer, transport layer, network layer, session layer, data link layer, like that. So do not interchange the layers. Do not forget any one layer also. Either layers from top to bottom or bottom to top, no problem in it. So why it is correct, why not it is like that, it is, it is. This is my device and this is the destination. Okay, this is my source and this is my destination. I want to send a packet to source to destination. For example, it is APC, BPC, A to B communication. So then the layers is like this. First one is application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So devices are connected physically, right? Physical layer represent physical connectivity. Then data is transmit from here to here and from here to here like this. Now data received at the physical layer, send at the physical layer, received at physical layer. Physical layer data is go to data link layer, network layer, then transport layer, session layer, and presentation layer and application layer. Mean data goes up like this to reach the B. Okay, destination understand. Okay, B understand what is my packet and what is the request and all. So it will going to reply you again. Application, presentation, session, transport, network, data link, and physical layer. And physical layer goes to physical layer and it is going to up. See, guys, when you are sending, when you are sending application layer to physical layer, layer 1 to layer 7. When you are receiving, when you are receiving, the data goes from, sorry, mistake. This is 7, this is 1. Okay. Physical layer to application layer. Okay. So that's why both the side is important. Both side are correct. But you have to remember either way. If you are already habituated to remember from physical layer to application layer, it is good. Otherwise, start remember the OSI layers from 7 to 1, means application layer to physical layer. And it is also one of the important question in your interviews. Compulsory. If you are sir, so many things are there, 7 layers. How to remember? I am not from CSC background. Guys, there is no part of CSC IT part. Any people can able to learn all these things because of it is a very low level technology. It's not required high level programming or anything. It is the very basic level things only. Even a 10th and intermediate guy can able to understand and remember. Okay, that's the point. Because I given a training in a earlier, so to the 10th class people, intermediate people, normal BSc background people also, BJC bio related science background people also. I given training. I given to mechanical, civil, BE, BTech, ME, MTech also I given. So these are a very basic level training. Compulsory read it, repeat it, you will remember. Daily studying, repeating will make you to remember things. The first layer is application layer, next is presentation layer and the session layer, transport layer, like that it will comes. One by one layer we will going to see guys. Application layer. The first layer is application layer. Application layer is at server and client side application. It means I want to send a, this is my client. Okay. Means my web browser. What is my web browser? Is an application. In the web browser, what I will do it? I will open a web page. I will open a web page. See this? I open a web page. And where is this web page is located? In the web server. How this web server become a web server? By in this one, there is an application, server application like a Tomcat or Apache web server, it is HTTPD. Okay, somewhere that is, there is a web server having their web application. So this applications. So it will having a web pages. You will get it from us. So I send a request through a protocol called HTTP request, and it will this web server application understand what is your request and what is the content is required. It will give HTTP response. Okay. So in this side, I use a web browser application to access a website. This side, a server using server application to give, understand, and communicate with the web communication. I'm using a ping command to ping, right? So I'm using command prompt to ping or to access remotely, like SSH access or Telnet access from here. But I cannot open a web page from here. Okay, in my old laptop, I have a file hippo. Sorry, not file hippo, it is, you know, WinSCP. I can use FTP, SFTP, SCP kind of protocols to access, upload and download files from remote server. It is free and open source SSH file transfer protocols, web dev, and what is this? Amazon S3 bucket, secure copy protocols also works with this. FileZilla. Okay, in a last computer, I have both the things. So FileZilla, like I have a remote server, I want to upload and download the files using FTP protocol. So I use FileZilla application. So this is my PC with a FileZilla application with a protocol called FTP. I can upload a file and download a file from remote file server. Okay. So application layer is about what application you are using. Client side application, server side application, what protocol and their port number is application side. Web browser is a client side application. Web servers like these applications. Okay, Microsoft Internet Information Service or HTTPD or Tomcat or like this. NGINX, these are server side applications. Outlook is a mail client application, so I can access my mails through my Outlook. Okay, of course, we can access through web browser also. So I can send and receive mails through my Outlook. I can send a mail, I can receive a mail, I can check my mail through Outlook. It is my mail client application. And what is mail server application? Microsoft Exchange is a mail server application, Zimbra, Dovcat, Squirrel Mail. It's a different mail exchange servers are there, kind of stuff. Putty, yesterday I showed a Putty application. In a Putty, using Putty, you can connect remote machines using SSH protocol and a Telnet protocol kind of stuff. In other side, server side, there must be a SSH server, SSH Telnet client server application has to run. So you want to access remote server, so using SSH and Telnet, CLI base, you can use it. So FTP, just I said FTP part. RDP, remote desktop protocol. Okay. mstsc is an application. It opens an application to connect remote server and access the remote server desktop from here. Okay. Remote desktop connection. So I have to give my remote server array or remote computer name or IP address, their username, click connect, ask for a password, give the password, and you will get it connected. So then we can able to see remote desktop machine. Okay, guys. So this is application layer is all about here where application you are, which application you are using, client side and server side, and the protocols are comes under this application layer. Understand, guys? Application layer.
Yes, sir.
Very good. Presentation layer. Presentation layer is a encoding and decoding data. So for example, I open this, I'm able to see the data, right? So I'm getting this data from the server, right? So what happened? This data, while it is sending, the data is encoded data it is. And once I received here, it is decoded here. So whatever the data is, you can see the data, there is a text, there is a pictures. Not only that one, guys, I said different protocols like mail kind of stuff or inside a mail data, or maybe you are accessing YouTube. It's a streaming, right? Video kind of data. So it converts the data into the ASCII format to binary format. It means completely low level data. Okay. So your text files, HTML files, JPG pictures, PNG pictures, GIFs, PDFs, docs, whatever you are sending through network, either as a web page wise or maybe it is upload, download a files, whatever it is, guys, it is converted to ASCII to low level format like a binary format. It is. In presentation layer, not only that one, it is compress the data. Data is huge data. It is we are going to compress the data. So then, um, like that. Okay, compress the data, encrypt the data. So data size can be reduced by compression and sending. Encrypt the data. So if you look at here, the protocol is HTTPS. It means that this server is sending me a data. Okay, so the data is encrypted using HTTPS protocol. Okay, SSL or SSL data is encrypted, and so it is received to me after decrypting. So encrypting the data while you are sending, when you receive it, it is data will be decrypted, then decompressed and decoded. Okay, so to secure data's transmission, we do encryption. Already yesterday I told HTTP, HTTPS. HTTP protocol do not encrypt the data. HTTPS protocol will encrypt the data. Okay. So presentation layer, encoding, decoding, compress, decompress, and encrypt and de-encrypt. The session layer. Session layer is about a create a session, maintain a session, and terminate the session. In whenever you see about a session layer in any material, it's of only one single line. It will create a session, maintain a session, and terminate the session. But session layer having so many other things also. Okay, I will tell one example also there, but so I will tell. So he user request something to the server. The data for whatever the it is responding, the data is in the different places. Pictures, for example, I am getting this. These things are there, so it is text is in some place, pictures are in some place, links are in some place, live data connectivity is some place. Okay, different places. Okay, data is can be there. What this session layer will collect all the things into one session. We try to deliver every data in the same session. Like I want to download a file. So it will collect data. So where is the downloaded file, location, who is asking? Guys, I open this page, but it is not asking any username and password. So I want to see what is the inside. So I have to log in. But without logging to initial login, it is getting because anonymous access, authentication for anonymous access. Okay. If I want to log in, then also I go to login, user information, then that in is going to authenticate and give. So whatsoever it is, it authenticate the people who are accessing the data. So it will authenticate. So user has a permission to access or no. It's an anonymous access. or if I speak user wise, it is access. So it will authenticate the users. So session layer also do authentication. One more point in a session layer, guys. Do not forget this thing part. I open Amazon.com. Amazon.com. So I want to buy something. So when I open Amazon.com, request go to Amazon server. So I got a page display and live updates also I can able to see. Okay. Now I check the product. I add to cart. I want to buy this item. Okay. So request go to Amazon again. So this is for a buying purpose. Just getting a page we are getting, but when you log in, so that login related information it shows based on your account. Now you check the product, you add to cart. Okay, you add to cart so that you want to buy now. So when you want to buy, so request go to anyway, all the requests reply from Amazon only. So each process it will do it, but I'm trying it is buying kind of stuff. So Amazon will send your card details. You insert your payment details. The payment will details will go to this Amazon. It send that details to your bank. Bank will verify your details. Yes, the details of user is correct. How much amount? For example, 1,000 rupees. So 1,000 rupees will be detected from here and it will send for confirmation. Bank will send you a confirmation OTP, right? So yes, OTP, right? Then it is 100 rupees is transferred to Amazon. Amazon confirms your order and that order will tell to you. This is order is your payment is confirmed, order is placed, and remaining things will happen. So like this. Okay. All entire process, this entire process want to done in a same session only. It has to be do in a same session ID. So to understand that one, so I will tell this guys, do not press back or refresh. Okay. So when you see, sometimes it will shows transmission is going on. So do not press the back button or do not refresh your page. We are processing your transaction. Please be patient. This process might take some time. Please do not hit refresh or a browse back button or a close this window. If you do, what happens? If you do refresh, what happen? New session will be created. And this session, what are the process is going on with this session? No one knows what happened. Money is detected, but order may not be placed because you disturb the session. In one process, things are going on. When you do refresh or a press the back button, you disturb the session. So this session is disturbed, session is destroyed. So things has to be done in the same process, it not be happen. Money may be detected and you don't know payment is placed or not. Okay, payment is placed or not. So one session is initiated. So obviously everything has to go with the same session only. Mainly in a payment type, transmission type means you're transferring something to remote or you're downloading from remote to local. So then obviously you should not disturb the session. Not only refreshment and the back button, guys. So internet disturbance, internet connectivity also disturb these sessions. Okay, so that is an example. Do not press the back button or refresh the page. If you do it, what happened? The session will be disturbed. You don't know what happened to the transaction. Payment can be successful, but order may not be placed. Payment can be failure, also possible. Okay. Even for me, it is happen. So when it is happen, I use my Wi-Fi network because it is very faster. So I connected to Wi-Fi. I try to book a ticket in a IRCTC. So I must almost came up to payment. So then when I'm doing that one, it is transaction failure. Why? Because of suddenly power is out and I my mobile phone switch it to 4G data. Internet is required, right? So then I have a Wi-Fi internet first. Later it is become 4G default data connection, right? So what happened? Session is changed to different network, different session. Session changes, transaction is failed. Even for a last time. So it's last week, I think I am trying to book a ticket in IRCTC at a 10 o'clock. What happened in our office? My mobile is connected to Wi-Fi once and disconnected and connected to 4G, 4G to Wi-Fi again. So I have done almost like a 2, 3 logout logins from a mobile application, IRCT application. Each time session changes, I cannot proceed it to next. Okay, that is the importance of session layer. By default, it is one single line we are writing, but it is there is a good stories about a session. Okay, so application layer, presentation layer, session layer. Best layer-wise data in a layer-wise. Every data is there. So each layer there is a data. Okay, application layer. So what are the application layer at the time of what are the application layer data, which is going to presentation layer. Okay, so what are the data? It can be a web page with certain protocol, web server. So that data is, we call it as a data only. This entire thing we call it as a PDU. Okay, guys, layer wise, whatever the layer it is, the layer data we call it as a PDU. The layer, what are the layer? Layer after processing of layer things, it is a PDU, packet data unit. In application layer, the packet data unit is called a data. And this data is go to the presentation layer. In the presentation layer, the data again compressed and converted into bit code like a binary. What are the data it is converts into binary and it is compressed and encrypted. So that PDU it as a data only, packet data unit. So that the total information we call it as a PDU. So okay, the PDU is data here. Whatever it is, guys, any layer data, we call it as PDU. Session layer, session ID is created, established. Okay. So the data is go to session layer. In the session layer, session ID is created. Session maintenance, session connectivities, to other servers or devices or an application. Okay, so after that, when this is also called as PDU, the PDU name is also data here. And this data is going to transport layer. Okay, in transport layer is providing end-to-end connectivity. End-to-end connectivity. It segment the data. It means it divided data into small pieces. Segmenting. For example, I want to transmit a data like a hello, how are you? So this is from A to B. I am sending. A send a packet. So like a sorry, this will be segmented. Just for our example, for understanding purpose only, guys. Really, it is happen in different way. For our understanding of the segmenting part, see it is. It divided data into small parts. I put a numbering on it. Means a sequence order number is placed on this things. Okay, numbering and sequencing. So segmenting the data means chop the data into small pieces. Each piece will be arranged with a number sequence. The first one is sent. First packet, first one is sent. It received at a destination. Destination will give an acknowledgement to the source. Meaning is source understand this first one is hello is reached at B and A send a packet to B, that is second one, then it is reached, then B is giving acknowledgement for a second packet. Third packet is sent, third is received or not, we don't know. It does not give any acknowledgement. I send fourth packet is received and it will give acknowledgement that fourth packet. So hello is reached, U is reached. Not governors. So our APC thing, this particular packet is not sent. So that is the main point in this segment. Okay, so we know data is destination received a packet or not. So again, I will send a packet. So once it is received, it will give acknowledgement. So R is also received now. If you add all these things, how it will comes in generally, hello, how you are. But is not in a correct order. How? Because of this. So it will be arranged in a correct order again. So again, it will be rearranged. Okay. So that is the advantage of a, transport layer, segmenting, numbering, and sequencing. And all correction, not error detection, guys. Error correction. Correction means whenever the packet is not received to destination, source will send the packet again. Okay. So because of that property, transport layer is generally it is error correction. So using segmenting, numbering, and sequence, it can able to arrange the data proper order. And if you destination, we can send the particular part segment to the destination. So what is transport layer do? Segmenting, chop the data into small pieces. Okay. Numbering and sequencing. So means it can able to arrange the data in proper order to avoid the conflicts. It will do error correction using this numbering and sequencing. Okay. it multiplex and demultiplex of TCP protocols into TCP and UDP. Guys, earlier we discussed about a protocols and with their port numbers. Each protocol, each protocol, either it is a TCP type protocol or UDP protocol or both. Example, TCP protocol, HTTP protocol. HTTP protocol is an example for a TCP. Okay. TFTP protocol is example for a UDP protocol. DNS protocol is TCP as well as UDP protocol. Both behaviors are there. Guys, TCP and UDP is not a different concept. It is because our protocols are TCP type protocols or a UDP protocol. TCP type protocols are acknowledgement based protocol. Means when I send a packet to the destination, if destination received a packet, it will give acknowledgement. Okay. Like I send a packets to the destination send an acknowledgement. Meaning is this destination received a packet. Destination received a packet. I send a packet, but I didn't get any of acknowledgement. Means source thing, destination is not received this packet. Okay, that is a TCP type of behavior. Means you send a packet, destination receive it will give you an acknowledgement. So means you will understand destination received a packet. Okay. For example, um, you order something. Once you are received a packet, immediately will get a delivery report. Means organization knows you received a packet. Now, olden days we have yeah, very simple guys. Tick marks. What is a gray tick mark represents? Message sent may not be received at destination. Double gray mark or double check marks. Message sent received at destination number. Okay. Two blue check marks. Destination we send a packet. Destination means we send information message. Destination person got the message or whatever it is, and he opened scene like that. This is a delivery responses. The same way, acknowledgement is nothing but a delivery response from the server. And what is about a UDP protocol? UDP, no acknowledgement. UDP do not have any acknowledgement. What happen? Suddenly it is off. Guys, can you able to see my screen?
Yes, sir.
Yes, sir.
Sir.
Very good. UDP type protocols are like this: source, destination, source send a packet, destination received or not, we don't know. Okay, destination received a packet or not, we don't know because it is not giving any acknowledgement to the source. Yes, TCP, UDP, we are learning, we are telling the differences. what exactly it is, what transport layer is doing with this TCP UDP, guys. A lot of different protocols: HTTP, HTTPS, FTP, SSH, Telnet, RDP, SMTP, POP3, IMAP, TFTP, DHCP, DNS. Okay, so NTP, NN. So different type of protocols are there. So these protocols are either TCP type protocol or UDP type. TCP type protocols are acknowledgement based, not TCP. TCP type protocols are acknowledgement based protocols. Means is we received a acknowledgement for that one. Meaning is destination received packet packet. Okay. So that's why TCP type protocols called reliable protocols, connection oriented protocols. Why reliable protocols? Source node destination received a packet or not. Source knows destination received a packet or not. And what is the another one? So connection oriented. Guys, connection oriented means not a wide or wireless type. Okay. A general people misunderstand. TCP means a wide type of communication. UDP means wireless communication. No, guys, no. Communication defines type of communication defines by protocols. TCP type protocol or UDP type protocol. Okay, not a connection, either wide or wireless connection. It's just a connection. Okay, so why it is called a connection oriented means both source and destination both are having a two-side communication. Means source and destination also is sending an acknowledgement. Source send a packet, destination received a packet and give a acknowledgement for that packet. It is means source knows destination is received a packet. That's it is connection oriented. UDP connection less protocol means again source send a packet, destination received a packet, but destination is not giving any acknowledgement means it's a one-way direction communication. Simple, you went to home very late. So your father or mother got angry and start scolding you. You don't speak anything, right? Just whether you listen or not, you're understanding or not, just you will keep silent. So it's a one-way direction. UDP protocol. TCP protocol, there is a general discussion like you want a money, you ask in parents, then they ask like a questions, you give an answers, or maybe you're giving some reply note kind of stuff. It means the source thing destination is receiving a packet. Okay. Transmission control protocol use the datagram protocol. So TCP is acknowledgement based, UDP is no acknowledgement based. TCP type protocols are HTTP, SMTP, FTP, SNMP kind of stuff, and UDP is DHCP and TFTP. Yes, DNS is a both TCP and UDP type protocol. It is. Reliable, non-reliable protocols, of course, TCP is a reliable and UDP is a non-reliable. TCP is a connection-oriented, connectionless protocol. Yeah, I didn't tell you one more point. It encapsulates or multiplexes the TCP and UDP protocol. Yes, every packet, it is every data packet is having some information. Okay. In your transport layer packet, there is a special session is like a TCP UDP part is there. Under TCP, what protocols we are using in this particular communication, that protocols or port numbers are located under TCP. All TCP type. In your communication, if in case you are using a protocol which is related to UDP, that protocols TCP box. So it's a multiplexer of TCP UDP means all TCP protocols comes under TCP multiplexing to it. Okay. And also transport layer will do flow control or a windowing. What is flow control or windowing? Guys, I am using a 1 Gbps connection. This is only 100 Mbps connection. I can send 1 GB per second data to this machine. But this destination cannot able to capture all the data, cannot accept all the data because it's 100 Mbps connection. It has a limitation to receive a data from here. So what is our transport layer will do it? So regulates. Means it will send this bunch of packets one at a time. Instead of sending one by one packet, it will send a bunch of packets depends upon post availability. Okay. I'm sending 10 packets at a time. I'm sending 20 packets at a time. Okay. Can you able to receive 10 packets at a time? Yes, means it will send. Can you able to receive 20 packets at a time? So I cannot means I will change my speed of delivery. So control and windowing. Source estimate the destination receiving packet capacity at a time in the flow control. Guys, already I told whatever the data in the layer that is called PDU. Application layer, presentation session layer, the data is the PDU is a data only. In transport layer, the PDU called as segment. TCP header plus PDU. So for your PDU, which is came from the session layer, that PDU means the data which is adding to your TCP header. What is this TCP header contains about your TCP UDP informations means the protocol information segmenting and numbering information is there in the TCP header. Your TCP header plus PDU from the session layer, then it is become a segment. Okay. This segment is sent to the network layer. This CP is sent to the network layer. Okay. We completed up to transport layer, network, data link, and physical layer only there. Guys, understand up to transport layer? Okay, okay. So application layer, presentation layer, session layer, transport layer. So for a transport layer, it is we are receiving a segment. Okay, this segment is sent to the network layer. In network layer, the PDU segment, okay, in network layer is dealing with the routed protocols and routing protocols. Routed protocols means logical addresses like IP addresses, IPX, SPX kind of stuff. Generally, we are using IP addresses type only, either IPv4, IPv6. So, routed protocols means dealing with an IP address part. Routing protocols means the routing protocols will tell you how to reach the destination or which way the packet has to go. In network layer, it is dealing with the two things. One is your logical protocols, means logical IP addresses, your IP address or logical addresses, and how to reach the destination using routing protocols. That information is added to segment. 1 second, guys. Yeah, okay, guys. So there is a network header is adding to our segment. Okay. The network header is added to our segment from transport layer. What is this network header contains? Source IP address and the destination IP address is adding to our segment. The total PDU we are calling as a packet. So in a transport layer, in network layer, what it is adding? Source IP address plus destination IP address is adding here to our segment. So this is we call it as a packet. So what is our PDU? Our PDU is packet. Packet contains source IP, destination IP, and some information about routing protocols. Okay, routing protocols information and our segment. And this packet is sent to the data link layer. This packet sent to the data link layer. In data link layer, again two sublayers. One is LLC, another is MAC layer. LLC means logical link control, guys. It is information about your WAN protocols. For example, you are communicating through WAN. WAN connectivity is there. How you connected to WAN? In a LAN, it is direct connection. Of course, you are connected to WAN means you have to define. In generally, guys, we are telling LAN, WAN. LAN is a small network, WAN is a wide network kind of stuff. Okay, in a single room or single floor or single building, we are saying LAN. But within a single room, we can create a WAN also. Okay, so what is the WAN? Define means different networks are connected through WAN link. Are we using WAN protocols called a WAN connectivity? All are LANs only. We are connecting one LAN to another LAN and we are communicating from one LAN to another LAN over the WAN protocols like a PPP, SDLC, MPLS, frame relay. These are the WAN protocols. These are the WAN protocols. Okay. Next, if in case you are connecting to WAN communication, then it is this related information added. Normally, so we are communicating in a LAN, then it is only MAC layer. MAC layer is media access control. You already knows every NIC has a MAC address on it. So it's in a 48-bit in number and a binary number represented in 12 hexadecimal. MAC address is also called as physical address, which is already we know it. Okay. In a data link layer, data header is added to your packet, and there is a data tile is also added to your packet. Means there is a data header, data tile is added to your packet. Data header contains source MAC address, destination MAC address. Okay, what it is contains source MAC address plus destination MAC address will be added. If it is a WAN protocol information plus CRC is also adding there. Cyclic redundancy check, which is used to check the data whether data is good or corrupted. Cyclic redundancy check is also added to here. It is used for error checking. So after data transmission, receiving data is received. So data will be verified with the error checking. Data is good or corrupted. So this is what we call our PDU, means source MAC address, destination MAC address, packet plus CRC. We call it as a frame. We call it as a frame. In data link layer, what we are getting? Frame. This frame is sent to the physical layer. What is our PDU? Frame. Okay. In physical layer, frame is converted into bit stream. Frame is converted into bit stream. The bit stream again converted into electrical signal. Bit stream means the data is converted into 0101 kind of stuff. Bit stream. Okay. Bit stream. This bit stream again based on your physical connectivity. Are you connected with the wire or wireless? Are you connecting with coaxial cable or UTP STP type of cables? Or are you connecting with fiber optical cables? Okay. Are you connecting with the fiber optic cables? Based on that, that's frame of the means the signal will be there, right? For example, it is a Ethernet connection, UTP STP connection. It is electrical type of signal. Your media, connecting media, your NIC, it is okay like this. If, for example, it is a wireless connectivity, then of course it's convert into radio signal. So in a different form, like a 2.4 gigahertz frequency, okay, and 5 gigahertz frequency radio signals. Fiber optical type of connectivities, then it is converted into light waves. Okay, so these are our total OSI model. Guys, got it?
Yes, sir.
Very good. So any one of you tell me just these 7 layers names. 7 layers names.
The application presentation section, transport network, and data link and physical function.
Very good. Very good. Okay. And when we are discussed about hardware, okay, okay. When we are discussed about hardware devices, I said hub is example for a layer 1 device. physical layer, switch is layer 2, data link layer, router network layer, layer 3. So these three layers are called hardware layers, bottom layers. These three layers we call it as the software layers, upper layers kind of stuff, because it is our decided okay. Software upper layer presentation, conversions, sessions, creations. These are upper layer part. Software layers, upper layers kind of stuff. Okay. In general, if it is a physical based training, guys, so definitely one by one I will make people to speak about it. Now it is online, so people are not ready. No, maybe it is difficult. I will tell up to here, this part only, then we'll take a break. Yeah, sound connectivity is also we are having a problem. External wire. So guys, again, I said this protocol port part, okay, right? So here we'll go. Again, I'm telling. So this is the source APC and this is BPC. I want to send a packet, so I'm sending some information to BPC through network. The first involvement is application. What client application it is? What protocol you are using? Okay, what is the address of destination? Okay, what type of communication? That is comes under application layer. In a presentation layer, whatever the data it is, it encode the data. Okay, encrypt the data, compress the data part. Application layer, presentation layer, session layer will create a session. It establishes a session. Okay, establishes, create a session or establish a session, maintain the session. And once we received our data, so we send it and we got it, the reply. You send a request and you got a reply, or you downloaded a complete data, means one transaction, the transaction completed, means the communication completed. So then session will be over. Again, we have to establish a new session. Okay. So establish a session. Network layer. Now next one is transport layer. Transport layer segment the data. So data divide into pieces, numbering on it. Okay, windowing. TCP UDP protocol suite. What are the protocols we are using here that kept in a TCP and UDP boxes like that. Next network layer is about adding a source IP address, destination IP address to our data. So this is a segment. This is packet. Data link layer is adds MAC address, source MAC address, destination MAC address, and CRC. Physical layer, physical layer. Okay. So it's a connectivity related. Okay, so electrical or a wide or wireless connectivity. It is. Of course, we send a data to the physical layer only through bit stream and convert into electrical and electric things. It receive a physical layer at a destination. So via switch or a hub or a direct connectivity. So it received at a physical layer in a destination PC. It convert this bit stream. It convert this bit stream to a frame. This frame go to data link layer. What is the frame contains? Source MAC address, destination MAC address, CRC. Using CRC, data link layer verifies the data. Data is good or corrupted. Error correction. So not error correction, error checking. It verifies data is good or corrupted using CRC value. CRC is an algorithm. It is use a value to check the data. It is generated from actually your data. And it understands source MAC address and destination. Destination MAC address is belongs to B's MAC address or not. Okay, destination MAC address is B's MAC address or not. And it will take a source MAC address aside. It write down source MAC address aside. What is source MAC address here? A's MAC address. You note down the ASPC MAC address. Next, what is after data link layer? So what is the content in between in this one? Packet, right? This packet is go to which layer? Network layer. In network layer, what happen? It take the packet. Packet contains source IP, destination IP, and that segment. Source IP and destination IP. What it will do, the BPC verifies is the destination IP address is belong to BPC or not. Destination IP, destination IP address is BPC IP address. Destination MAC address, BPC MAC address. In case the destination IP address is not the BPC IP address, it is drop the packet. If it is right, then it is accept the packet. If it is BPC IP address, accept it. Not BPC IP address, drop the packet. No further communication, no further layers. Okay. And it note down the source MAC address. What is source MAC address? Yes, MAC address. So keep it aside, guys. I will tell what is this node point. And we are getting a segment from it. In a transport layer, these segments will be collected. Means segment number 1, segment number 2, segment number 3, order numbering, ordering, everything will be done in transport layer only. It means all segments will be collected as per the windowing and as per the numbering and sequencing. The all packets will be collected and arranged in the proper way. So now the complete packet is at transport layer. That's why transport layer is a end-to-end connectivity. End-to-end connectivity means that's whatever we are sending a data, it is segmented, numbering and sequencing and windowing, TCP, UDP, multiplexing, everything is done at this transport layer, and the entire packet is reassembled at again transport layer only. And session layer verifies your session ID, save the session ID aside for a further transaction. I have space is not there. So next one is presentation layer. What is presentation layer? Is data is encrypted while I'm sending. I encrypt the data. So when I received it, I decrypt the data. Encrypt and send, decrypt and receive. If in case data is encrypted, if you are using encrypted protocols. Okay. Next, compress and decompress. So data is compressed here, decompressed here, encrypted here, decrypt here. Encoded here, decode here. Means original data is in the original data form. Data is in the form of encryption, compression, and encoding form. Now it is actual data form, it is there. And application layer will respond what is the user request, what is the data, where is the response, the understand what protocol he use, and which application has to respond, that one application layer place. And it will again, as per your request, it will try to resend the data. Again, application to presentation, encoding, decoding kind of stuff, session, transport, network, data link, physical to physical, data link, network, transport, session, presentation, and application again. Okay. So this is how data is sending and receiving. While you are sending application to physical layer, when you're receiving physical layer to application layer. Guys, understand what I am trying to say, this part?
Yes, sir.
Okay, great. In here, I try to put this thing. When I receive a packet, when a device received a packet, means the packet contains source IP address, destination IP address, source MAC address, and destination MAC address. So I received it. It received means source IP means other device, right? So for in this our case, APC IP address. Source MAC address means APC MAC address. B received a packet. Okay. And it will put in a one table. These two things, they put it in a table called a ARP table. Address Resolution Protocol table. Okay. ARP table. What is a ARP table, guys? I said simply source MAC address, destination MAC address kind of stuff. But in a reality, what will happen when you are sending from A to B? A already means you are a person is operating, so you know the B IP address. We know the B's IP address, but we don't know the B's MAC address initially. We don't know the B's MAC address. So instead of B MAC address, we are using FF, 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 FF. Like how many Fs are completed? So many. It says 6. Now we have to go to base. Yeah. This is totally B's MAC address. So instead of original B's MAC address, MAC broadcast address. This address we call it as a mask because I don't know the B's MAC address. So I'm using B's broadcast address. Okay. Same as we don't know A's MAC address. MAC address. But how devices will learn other devices MAC address using ARP, address resolution protocol. Device received a packet. The packet contains the sender's IP address and MAC address, right? I received a packet. The packet contains sender's IP address and so what I will do? Put a sender IP address and sender MAC address in a table. What is the use of this one, guys? Next time when I'm sending, so now I know the IP address, it is belongs to the this particular MAC address. So I no need to do second time a broadcasting kind of stuff. I no need to do it. Okay. Simply go for this. Okay. My PC knows my PC IP address and this one. So for example, I want to ping I don't have any other device now. See, just I send a request and I'm reply. So I received a packet. I send a packet and received a packet. ARP space hyphen A. So this is my PC IP address. What happened? Sorry. There's some problem in this. Okay. This is my IP address. This is someone's IP address and their MAC address. This is someone's IP address, their MAC address. This is someone IP address, their MAC address. This is someone IP address. So when I sending or receiving a packet from different devices, when I receive it, I will take their IP address and MAC address. I will keep it. If I want to ping to this particular device, I'm pinging to that particular device 172.16, 194, 118. Okay, whether we are getting ping or not, that is a different thing. But I am sending a ping request, right? So my IP address, my MAC address is sending, source IP is my IP address, destination IP address, destination PC's MAC address is a clearly it is sending. If I don't know the destination PC's MAC address, I will send as a destination MAC address as this one. I'm telling you again, guys. I send a packet to the certain device. I don't know their MAC address. So what I will do, I use this as a destination MAC address. If I know, if I know my remote device IP address and their MAC address, so I'll use my destination MAC address as this one correct. I don't know, I will send like this. If I know, I send a proper one. But usually we can also learn from it. So we are going to learn other devices MAC address when you receive a packet, and other devices will learn your MAC address when you are sending a packet. Once it is received, it will learn the MAC address using ARP protocol. ARP space hyphen A will display the ARP table. It displays the ARP table. If in case, guys, you are in a secure networks, security is a first priority. Means a destination received a packet, okay? A destination received a packet. The packet contains sender's IP address and sender's MAC address, and destination IP address and destination MAC address. At receiving side, you create a some program must be matches. Means source IP, destination IP. Destination source IP, destination IP, source MAC address, destination MAC address as per their devices. Means these two things must be matches. Source IP, source MAC address must be matches. Destination IP, destination MAC address must be matches. Then only I will accept the packet. In secure networks, what they will do, so they will bind it. Source IP, destination IP, source MAC, source IP, source MAC address must be matches. Destination IP, destination MAC address must be matches. Okay. So in that one, so what they will do it, they wantedly add to the servers, mainly in the servers, they will do it a static entry. So s- means someone is sending packet to me, right? Their IP address, their MAC address, I will add here. So I will add in this entries their IP address and MAC address. Both are matches, accept the packet. Don't matches, don't accept the packet. So you want to enter statically, this is the command. Yeah, you don't need to understand 100%, guys. Understand what is ARP, address resolution protocol. Address resolution protocol. Okay. What is address resolution protocol? It maps your IP address and MAC address. So, so at BPC, when it is receive a packet from A, it maps APC's IP address to A and to MAC address of APC. So the next time it is sending, it use this one. Okay. These are the commands. So statically, if you are enter this one, you want to see. Okay, I have taken a lot of time. Okay. No, no, last one, guys. This is the last one. Guys, we are all using TCP model. So this TCP protocol suite, we are saying it. And this one is also called as DoD model, means because we used this one as a defense model, actually it is. Okay. So OSI model to TCP comparison. It does not mean, guys, TCP is came from OSI. No, no. TCP actually exists earlier than OSI model. But there is a very side by side comparison is there. So that's why we are comparing. I put a color marks mainly for understanding. So which one is which one? Okay. Application layer at a TCP IP protocol suite is combination of three layers: application, presentation, session. These three layers duties done by this single application layer at TCP. Okay. So OSA model having three. So this application layer, presentation layer, session layer, three layer duty means these three layer protocols things are done by application layer. Transport layer is transport layer. What are the OSA model transport layer is doing? Same thing done by TCP IP transport layer. Network layer is what are the network layer doing? Like a source IP, destination IP kind of stuff done by an internet layer. In this one, we call it as internet layer. Data link layer and physical layer is a network access layer here. Means in TCP IP, four layers: application, transport, internet, and network access layer. Application layer having a application layer doing three layers duty of application, presentation, session layer of a OSI model. Transport layer is a transport layer, internet is network layer, network access layer is a data link and physical layer. Guys, we have a hub physical layer, switch data link layer, and what we say router is a network layer. Example I said. What about your NIC cards or LAN cards? It comes under network access layer because physical connectivity plus data link layer means MAC address. MAC address. That's it is a network access layer, or we can say data link layer part also. Okay, either purely OSI model means it is a data link layer. So in a TCP IP, network access layer is a correct one. So this is about your OSI model. Next, we will see after a small break, we will see about a IP addresses. Okay. So I have taken long time. So take a 15 minutes break, guys. Come back at 5 o'clock.